Welcome to NetBots Cloud. My name is Emmanuel, your DevOps facilitator. Our DevOps program is exactly what you need to master the core practices and technologies that drives the modern day software and operational landscape. This video course, The Ultimate Guide to Mastering DevOps, is designed to provide learners with a comprehensive understanding of DevOps. DevOps is a set of practices that automates and integrates the process between software development and IT operation teams. Its goal is to build, test, release software faster and more reliable. I will walk you through the essential skills you need. You need to understand that there are DevOps fundamentals. First, we have Linux. Almost every tool in DevOps run on Linux, so you need to learn how to navigate shells or manage processes and understand file permission and so on. So knowledge of Linux and Linux command and scripting is foundational but very powerful part of DevOps skills. Operation systems are basically foundation of computing environment. Whether you want to run pipelines or spin up servers for Kubernetes, it's all powered by Linux. Most Docker containers uses Linux images, and as a DevOps engineer, you will work most of the time with remote servers on the cloud which use Linux operating systems, so this skill is essential. Linux is a backbone of server and development environment. As a DevOps engineer, you'll be setting up and maintaining the infrastructure where application runs. Most servers use Linux, so getting comfortable with it, especially the command line, is crucial. We are starting with learning Bash, which is the most commonly used shell and scripting language in Linux. Networking is a crucial skill for a DevOps engineer, as modern software systems are rarely isolated. They communicate with other services, database, and users across network. Understanding networking principles is essential for building, deploying, and maintaining this distributed system effectively. You need to understand networking is all about how computers communicate with each other. Think IP addresses and protocol. You need to understand how data move around, secure data, and troubleshoot network issue. With Wireshark, you will learn how concepts like OSI, TCP, IP model, IP address and subnetting, DNS and DHCP, networking protocol like HTTP, HTTPS, FTP, and SSH, firewalls and security group, and basic network troubleshooting using tools like ping, traceroute, and netstat. Imagine a DevOps engineer is like a delivery truck driver for a software company. So think of software as packages and users as customers. The DevOps engineer need to deliver packages to customers. Think of internet and internal connection as road. Truck drivers as DevOps engineer. The internet and internal network connection are the roads the truck driver needs to use to get the packages to his destination. Why is understanding the road or networking important for the delivery truck driver or the DevOps engineer? 1. Finding the right address. The driver needs to know the correct address, IP address, domain name, or the servers or users to deliver the package. Without this knowledge, the package gets lost. 2. Choosing the best route. The driver needs to understand different routes, network paths to ensure the package is delivered quickly and effectively. Avoiding congestion. Network bottleneck is crucial. 4. Avoiding obstacles. The driver needs to know about roadblocks or detour, firewalls, network outrage. This might prevent delivery and how to navigate around them. Ensuring secure delivery. The driver needs to know how to use secure routes to handle the package carefully to prevent thefts or damage during transit. Troubleshooting and delivery issue. If a package doesn't arrive, the driver needs to understand the road well enough to figure out where the problem might be. Was there a roadblock? Did they go to the wrong address? In short, just like a delivery truck driver needs to understand the road to deliver packages effectively, a DevOps engineer needs to understand networking to deploy, manage, troubleshoot software applications that rely on network connection to function. Without basic networking knowledge, the DevOps engineer would be lost and unable to get the software package to their intended users. Version control, and specifically Git, is absolutely fundamental to becoming a successful DevOps engineer. It's not just a nice to have skills, it is a core competence that underpins many DevOps practices. Core importance of Git to a DevOps engineer. One is collaboration. DevOps is all about collaboration between development and operation teams. Git provides a shared workspace and mechanism for teams to work on the same code base simultaneously without conflicts. Automation. Many DevOps automation pipelines for building, testing, and deploying codes are triggered by change in DevOps repository. Git acts as the source of truth for the application code, infrastructure as code. DevOps engineers often manage infrastructure using code. Git is crucial for versioning and managing this infrastructure configuration just like application code. Now, next you have configuration management. Tools like Ansible, Chef, Puppet, used extensively in DevOps for managing system configuration, often store their configuration in Git repository. Rollback and recovery. If a deployment introduces a bug or cause issue, Git allows for easy rollback to previous stable version of the code or infrastructure configuration. So imagine you are the project manager overseeing the construction of a large multi-story building. Now, without version control, which is a paper blueprint, different teams, architects, electricians, plumbers, structural engineers are working on various aspects of the building. Blueprints are constantly being updated. Keeping the track of the latest version is a nightmare. If an electrician uses an outdated blueprint, it can lead to costly rework or delay. Collaboration is cumbersome. Relying on a physical meeting, managing sharing of documents with Git, a centralized digital blueprint repository, collaboration is made easier. We need to get comfortable with Git and make sure we learn basic Git commands like git clone, commit, push, pull, branching and merging, resolving merge conflicts, working with remote repository and tools like GitHub, GitLab, and Bitbucket. And it's very comfortable, very important to understand that in DevOps we have this common concept that we call everything as code or X as code that includes the underlying concept like infrastructure is code, configuration is code, pipeline is code, security is code, and so on. So this is like an umbrella term, and Git actually plays a crucial part in all this. It seems we code a lot of configurations that previously were done manually on a local computer by some engineer somewhere. So we code configurations, we code infrastructure creation, we code the pipeline logic, we code every type of automation logic in our system and so on. And that code we leave in a repository which all the team members can access, and using various Git features can collaborate on that code, like creating merge requests, resolving conflicts, and creating branches, using various Git workflow and so on. So you need to learn these Git features that lets team collaborate on code change efficiently. So this is another skill that you need across multiple tools and DevOps concept. Whether you're writing a pipeline or infrastructure configuration, a Kubernetes manifest file or application code or whatever. Next is cloud computing. Next is cloud computing. The importance of cloud to DevOps is fundamental as it provides the infrastructure and tools necessary to streamline and automate the software development and deployment lifecycle. Here's a breakdown and a simple analogy for you to understand. Setting up a food truck business. Imagine you're starting a food truck business. The traditional approach is on premises. You'll need to buy your own truck, kitchen equipment, generator, and storage. If the business is slow, you're stuck with unused costly equipment. If the business booms, you might struggle to keep up with demand, lacking the space or equipment. Now, the cloud approach. You rent a fully equipped food truck and kitchen space for a service provider. You can easily scale up, by renting additional equipment or trucks during peak hours or events. Online platforms allow for easy ordering, inventory management, and communication with suppliers and staffs. Automated systems handles online order and delivery coordination, streamlining operation. In this analogy, the rented food truck and equipment represent cloud infrastructure. The online platform and automated system represent DevOps tools and practices. The ability to scale up or down represent this cloud scalability. The ease of coordination and communication represent the cloud collaboration benefits. Just as the cloud enables a more agile and efficient food truck business, it empowers DevOps teams to deliver software faster, more reliable, and at a low cost. Next, we have continuous integration. Now, continuous integration, or as you may know, CI/CD, automates the integration and deployment of code changes, allowing for frequent and reliable release. So Jenkins is a powerful tool for setting up CI/CD pipelines, but other popular tools like GitLab CI/CD, CycleCI, our main focus is how to create and manage Jenkins pipeline. Get familiar with writing Jenkins files, learn how to integrate, automate tests into your pipeline, understand how to automate the build process for your application, explore how to automate the deployment of your application to various environments, and so on. In a nutshell, why is it crucial to DevOps? Now, one is faster and more reliable building. Imagine you're building a complex Lego castle. Instead of waiting until you have all the pieces to start, you build small sections like a tower or a wall regularly. CI is like checking each small section as you build. So CI is continuous integration. So as you build, you check to ensure it's correct and fits with other sections. If there's a problem, you catch it early, preventing a catastrophic collapse later. Smooth, consistent assembly. CD, continuous deployment, is like having a system that automatically adds each completed section to the castle without you having to manually place every brick. Once a section is ready, it adds smoothly and reliably. Also imagine, once the castle is complete, it is automatically placed on display. This would be continuous deployment portion. Less chaotic, more efficiency. Without CI/CD, building the logo capsule would be chaotic. You will have pieces scattered everywhere and you would know if this fits until the very end. This would lead to errors, delay, and frustration. CI/CD brings order and efficiency to the process, making it faster, smoother, less prone to error. Faster feedback. If a castle piece doesn't fit, you know right away. If you wait to the end, it will be much harder to fix. Same with codes. If a problem occurs, CI/CD quickly notify developers, enabling faster fix. In essence, CI/CD automates the building and assembly to your logo capsule, which represents the software. So your logo capsule represents the software, ensuring that each piece fits, which is the pieces are the code changes, is correctly built and integrated smoothly, leading to faster, more reliable, and less error-prone process. This is exactly what makes DevOps thrive. Containerization is all about packaging an application and its dependency into a container to ensure it runs the same everywhere. Docker is a go-to tool for this. We will learn how to create Docker images, get familiar with starting and stopping and managing containers, learn how to write Docker File Explorer, how to define and run multi-container application using Docker Compose, and so on. Managing orchestration tools like Kubernetes, help automate the deployment, scaling, and management of container application. The tools are essential for managing complex application in production. You will understand the key components such as pod services and deployment. You will get familiar with managing resources, learn how to scale your application as well. Containerization and container orchestration are vital components of modern DevOps practices. Significance: live streaming the software development and deployment lifecycle. Here is a breakdown with an easy to understand analogy. First, containerization. What it is: packaging an application and its dependency into a self-contained unit called container. This ensures the application runs consistently across different environments like deployment, testing, and production. What are the importance? So consistency eliminates it worked on my machine issue. So there's sometimes you have an application, you test it, it works on your machine, but it gives an issue somewhere else. So with container orchestration, this issue is eliminated. Now, portability. Container can run on any system that supports them. Efficiency, lightweight and resource efficient. Isolation. Container isolate application, preventing conflicts. Container orchestration. What is it? Okay, automating the deployment, scaling, and management of container. Now, the importance: scalability, easily scale application up and down based on demand. High availability, ensure applications remain available even if some containers fail. Automate deployment, simplifies and automates the deployment process. Imagine you are moving your entire house across the country. Traditionally, before container, you would have to pack everything loosely into a truck. Items could get damaged, mixed up, or lost during move. Setting up your new house would be chaotic and time consuming. Different rooms have different needs, and packaging everything the same way would be very inefficient. Now we have containers. You pack each room belongings into separate labeled boxes, which are containers. Each box contains everything needed for the room, which are application dependencies. So application dependency means each box contains everything needed for that room. So the room for your kids, everything is packed in one box. The room for your food, everything is packed in one box. Your personal room, everything is packed in a box. That is application and dependencies. Box can be easily loaded, transported, and uploaded without worrying about capability issues. The boxes are all standardized so they can be moved by any forklift or truck. Container orchestration, managing the moving process. So container orchestration is about managing the moving process. You hire a moving company, the user system, to track and manage all your boxes. The system automatically assigns boxes to trucks, optimizing loading and uploading, and handle any issue that arises. If a truck breaks down, the system automatically reroutes the boxes to another truck. The moving company ensures that all boxes arrive at your new house on time and in the right order. If you need more room, the moving company can quickly send more trucks. In this analogy, boxes represent containers. The moving company system represents container orchestration. Packing items into boxes ensures consistency and portability, just like containerization. The moving company management system automates and optimizes the moving processes, just like container orchestration. Essentially, containerization allows you to package your application neatly and consistently, with container orchestration automates the management and deployment of your application, making the entire DevOps process more efficient and reliable. Because of the complex nature of Kubernetes, most companies prefer their Kubernetes clusters are managed on the cloud platform like EKS on AWS. So the cloud provider manage a lot of the work and administration of Kubernetes for you, especially the parts related to the cloud resources themselves, and they do it better often than you. So you can just focus on running your services and application. All DevOps engineers should know how to run these services. Even if they are easy to run, they are still complex because there's a lot of work that remains on your side. That is how complex Kubernetes is. Infrastructure as code involves managing and provisioning computer infrastructure through machine-readable configuration files. Popular tools include Terraform, AWS CloudFormation, and Palomi. Our main focus is on Terraform for its complexity and widespread use. We teach a solid foundation in Terraform. You will understand the basic concepts like provider and resources. Get familiar with writing Terraform configuration files. Learn how to use Terraform models, as well as an advanced concepts such as workspace and remote state. These are tools that gives you the power in your hands to automate almost everything, to build up the entire cloud infrastructure in Kubernetes on top of it from scratch using automation script. So think of infrastructure as code tools like composer of music. So Terraform and Pulumi can be used by teams to manage resources across multiple clouds, to track any changes, to maintain consistency, and as well as I said earlier on, you can build everything from scratch at a high level of complexity. Finally, let's talk about monitoring and logging. Monitoring and logging are absolutely critical for a DevOps engineer, acting as their eye and ear in a complex world of software system. Monitoring provides real-world insights into system performance, allowing engineers to identify and address issues before they impact users. Logging captures detailed record of system events, enabling engineers to trace the root cause of a problem. Monitoring and logging tools such as Prometheus, Grafana, ELK Stack, and FluentD track the performance and health of your application and infrastructure. You will learn the architecture and data model of Prometheus, get familiar with collecting metrics from various sources, learn how to write queries to extract and analyze metrics data, understand how to set alerts, and so on. Imagine a DevOps engineer as a doctor in an intensive care unit, and the software system they manage as a patient. Just like a doctor monitors a patient's vital signs, like heart rate, blood pressure, oxygen level, a DevOps engineer monitors system metrics like CPU usage, memory, network traffic. If a patient's heart rate spikes, the doctor knows something is wrong and takes immediate action. Similarly, if the system CPU suddenly increases, the engineer investigates. Alarms are set for when vital signs are outside the normal ranges. This is the same as setting alerts for when several metrics are outside of the normal range. A patient medical history like logs provide valuable information about their past illness, treatments, and reaction. System logs provide a detailed record of events, allowing engineers to trace the sequence of actions that led to a problem. If a doctor needs to know what medical condition the patient is going through, they look at the patient medical log. If a DevOps engineer needs to know what code we run and what error were produced, they look at the system logs. Now, there are stages of paths of learning and understanding DevOps. Each represents a layer of DevOps knowledge that you can build on top of. Now, there one important element that is not really a tool or a concept that you can learn in isolation, but rather something that is ingrained or should be ingrained throughout the entire process of DevOps and as part of each of every single technology that we discussed, and that is security. Security is absolutely paramount for a DevOps engineer, not just a secondary concern. Integrating security practices early and continuously throughout the software development life cycle is a core tenet for modern DevOps, often referred to as DevSecOps. Importance of security to a DevOps engineer. Protecting sensitive data. DevOps engineers often manage systems that handle sensitive user data, financial information, or intellectual property. Security vulnerability can lead to breach, resulting in significant financial loss, reputation damage, or legal consequences. Maintaining system integrity and availability. Security measures protect systems from malicious attacks that could disrupt services, corrupt data, or even take down an entire infrastructure. DevOps engineers are responsible for ensuring systems are reliable and available. Building trust and reputation. Organizations that prioritize security build trust with the customers and partners. A security breach can erode this trust quickly and have long-lasting negative effects. DevOps engineers play a crucial role in building secure systems that maintains this trust. Building and maintaining high security bank. Let's take that as an example. Imagine a DevOps engineer as a chief architect or head of operations for a brand new high security bank. Without security focus, ignoring security in DevOps, the architect focuses solely on building the bank quickly and effectively, using standard materials and design. The operation teams focus on smooth day-to-day operation, like processing transactions and managing accounts. Security is an afterthought, with maybe a few basic look on the door or a couple of security cameras installed later. Result: the bank is vulnerable to robbery, burglaries, and internal fraud. Customer trust is low, and the bank is constantly at risk of significant losses and reputation damage. With security integrated, which is DevSecOps, security first design. The DevOps engineer designed the bank with security as a top priority from the beginning. This includes reinforcing walls, secure vaults, advanced alarm system, and multiple layers of protection. Continuous security check. Throughout the construction process, the DevOps engineer, heads of operation, implements continuous security check like penetration testing, the alarm system, and reviewing security protocol. Automated security measures. Security measures like surveillance system, access control, and fraud detection are automated and integrated into the bank operations. Proactive threat monitoring. The DevOps engineer constantly monitors for potential threats and vulnerabilities. So security, as I said, is extremely important, especially in DevOps, where so many different technologies are integrated with each other, where every single integration actually exposed in a tech surface. So that means while learning each and every one of these tools, you need to learn them with the security best practices, as well as I mentioned at the beginning of your learning. Every single one of these tools is exactly in order in depth in our DevOps program. And if you check the DevOps job requirement, no matter in which country or in which company, you'll see this is a pretty complete list of what an experienced DevOps engineer is actually expected to know and what we teach efficiently in our DevOps program. Which means we take every beginner of DevOps, but we don't just prepare you with some entry-level knowledge, just enough to get you an interview or just enough to get you food into your DevOps job, because that's not a goal. What we do, we strive for, we prepare you to crush every interview and stun the interviewer, making them question how come you know all this stuff, even though you have little DevOps work experience or no DevOps work experience, and perform confidently in your DevOps job after you actually get hired. So that's the level that we are aiming for, and that's what we prepare you for with our DevOps program. Now, I hope this video gave you some guidance in your journey of learning DevOps. Thank you for your time.